Hi guys, I hope you're all doing well. Today I'm going to be doing a video just going over how to approach the nomenclature questions in organic chem, especially preparing for the exam. So usually they like to give it in the form of, they just give you a list A to F with structural formulae and sometimes condensed structural formulae or the IUPAC name, and then all the questions are revolving around those 5 or 6 organic molecules, right? So I'm going to be looking at each and how you can help yourself to prepare for the exam. I'd like for you to first attempt these questions as I'm going along. Just pause and attempt, and then come back to see how you have answered them, whether you've answered them well or not, and also get to see how I explain around those topics, right? So here they say, for each of the following, write down the homologous series, functional group, name of functional group where applicable, general formula, IUPAC name or structural formula, right? So for naming, if you remember the rules, what is important is to prioritize the functional group if you have one, and to number in such a way that you give the lowest numbers possible to the substituents if you have substituents, and no double bond, functional group, alcohol, and so on, right? So if you look at that C, it says name where applicable. So I'm going to be focusing on the 4 names that you're expected to know for your ketone, for your aldehyde, for the carboxylic acid, as well as for the alcohol. As for the other functional groups, you're not required to know the names, so I will not be focusing on those, hence I said where applicable. Right, the first one says you have an organic molecule, you'll be given like this. So I'm first going to identify the homologous series and write it down, functional group. So if you check here, I've got some chlorines, I've got some fluorines, a fluorine, and single bonds only between adjacent carbon atoms. So this means that the homologous series must be a haloalkane, right? And then if you check again, the functional group of a haloalkane, that would be for B. So alkane means single bond between adjacent carbon atoms, right? We already know that. The X there stands for chlorine or bromo or fluoro or iodo, right? So that's the functional group. You're not expected to name the functional group in the South African grade 12 syllabus. So I'll move on to D. D says write down the general formula. So I often say the general formula, once you know the functional groups, it's not something for you to cram, really. Because if you look here, I have 2 carbons, and I have, if these are hydrogens, then that would be 1, 2, 3, 4, 5 hydrogens and a halogen, right? So write down the general formula in terms of N. So for, let's say for 2 carbons, I have twice the number of hydrogens, 1, 2, 3, 4, plus 1. So that's H2N plus 1 and a halogen, right? I think that's quite easy to remember. And then let's get on to the naming, which is what most people find a bit challenging, right? So if we are to name here, if we are to name, sorry about that. If we are to name, I always break it down into the prefix, parent, chain, suffix, and then writing down the full IUPAC name, right? So the prefix are your substituents. So you're gonna have to identify or find the longest chain and then number it correctly. So remember, these are substituents are chlorines and the alkyl groups, which means you number to give the lowest number possible to the substituents. So let's check. If I number from the side, 1, 2, 3, 4, 5, that will be my longest chain, right? And then I've got 2 substituents on the second carbon and 1 substituent here and another one on the 4th carbon. Had you numbered from the left, 1, 2, you'd have 1 substituent on the 2nd carbon and another one on 3, and then 2 substituents on 4. So you realize that if you number from the side, there is less substituents that get the low position of 2. So you have 1 substituent on position 2, as opposed to this side having 2 substituents on position 2. So you choose to number from the side, right? So if you look at my longest chain, it's going to be 5. So that's pent. This is a haloalkane, so the suffix is ane. Now let's look at the prefix, and you always name in alphabetical order. So you have chloro, followed by fluoro, followed by methyl, right? So it's 2.2 dichloro, 4 fluoro, 3, let me just push this back in, 3 methyl. Those are all your substituents accounted for, right? So now if you put the IUPAC name together, it's going to be 2.2 dichloro, 4 fluoro, 3 methyl pentane. That's quite long, but yes, that's your IUPAC name. That would get you about 3 marks, right? Let's move on to the next one. The next one, if you look at the structural formula, has a triple bond. So the homologous series there is an alkyne, right? Functional group, what is important is that it details basically that specific feature that you find in that homologous series. So you know for alkynes that there must be a triple bond between 2 adjacent carbons. So this is the functional group. And carbons must always have 4 bonds around them. So the other 2 bonds are going to have to be there. That can be anything else, but there must be a triple bond. And then the general formula, if you check here, if for instance I had 2 carbons, you'll notice that if these were hydrogens, these would be 2 hydrogens, right? So the general formula is CnH2n minus 2, right? And then this is actually D. And then for E, it says, write down the IUPAC name. Again, it goes back to identifying the correct way of numbering, or the direction that you're going to number, and identifying the longest chain, right? So if you check here, you have to prioritize the double bond, so it must have the lowest number possible. So if you number from this side, this would be your longest chain. If you had numbered all the way to here, then your longest chain would be 5, which means that's actually not the longest chain. So you number going down here, then you'd have a long chain of 5, or rather 6 carbons, right? Now when it comes to the naming, you've got these substituents, and these are both methyls. So you've got 2 methyls on carbon 4, so that's going to be prefix, parent, suffix, and IUPAC name. Your longest chain is hex, 6 hex, and your suffix is, you've got an alkyne. Your suffix is basically your functional group. So it's an alkyne in position 2. Right? And then you've got your 2 methyls, both on position 4. So you have to mention that you have 2. Hence, the 4.4 dimethyl, right? And then the full IUPAC name, now if you put it all together, is 4.4 dimethyl hex 2-ine. That's the full IUPAC name. Moving on to the next one. So if you look at number 3, you will see that it also has, sorry about that, there's a bit of thunder on this side. There's a thunderstorm. So if you look at number 3, you'll see that it also has a halogen. So just like number 1, this is a haloalkane. I'm not going to redraw the rewrite the functional group and all that. So this is a haloalkane. I'm just going to get straight into the IUPAC name. So your prefix, parent, and suffix, right? So you have to obviously identify the longest chain. If you look there, if you number from the right, then it's 1, 2. Your first substituent is in carbon number 2. If you number from the left, your substituents are also on carbon number 2. But you must give as many of the substituents the lowest position possible, right? So you number from the left, because then 2 of the substituents get a lower position, carbon position, right? Now, when I am naming, I don't name in numerical order, but I name in alphabetical order. So I'm going to start with the 4-chloro, and then I'm going to have 2.2 dimethyl, and then I'm going to have a parent chain of 5, so that's pent, and this is an alkane. So that's IUPAC name, (4-chloro) 2. So you notice that the comma is only between 2 numbers, and the dash is between a number and a letter, right? 4-chloro 2.2 dimethyl pentane. That would be my IUPAC name. Moving on to number 4, you are given a condensed structural formula. So I always say it's best to write what you see. So when you are having a situation where you are given a condensed structural formula, I suggest that you start by writing out the structural formula first, right? So you know that a carbon must have 4 bonds around it. You have 1, 2, 3, 4, 5 carbons. Right? And then they told you that there's 1 hydrogen here and 3 here. So you'll notice that these 2 carbons are actually missing 1 more bond. So there must be a double bond between the 2 carbons, right? Which means this must be an alkene, right? functional group must show that it's a double bond between two adjacent carbons. So that's what I have there. And then the general formula, you'll see if I have two carbons, if all these were hydrogens, then it means I'd have 4 hydrogens. So it's CnH2n, which is 4. 2 times 2 is 4, right? So that's why I have 2n there. And then let's get on to the IUPAC name. So this one is relatively easy. You prioritize the double bond. If you number from the left, then the double bond is in position 3. If you number from the right, then the double bond is in position 2. So we number from the right. Right? Which means I don't have any substituents. So there's nothing there. My parent chain has 5 carbons. And I have my functional group in position 2. And it's an alkene. So my IUPAC name is pent-2-ene. Right. Moving on swiftly to number 5. Number 5, you're given a IUPAC name, propan-1-ol. So that right there is the suffix for an alcohol, right? So like I said in the previous one, I always like to first, if I'm given the IUPAC name, first write out the structural formula. So prop means 3 carbons, and then it's an alcohol, right? So A, which is the homologous series, that's an alcohol. Hydroxyl is the name of the functional group, right? I just mixed these two up. I should have started with the functional group first. So the functional group is, it's a C. Actually, you don't need this one. There must be an OH bonded to a carbon to form an alcohol, right? And then D says write down the general formula. So you'll see right here, if I have 1 carbon, then I have 1, 2, 3, 4 hydrogens. So that's 1 times 2 is 2 plus 2, that's 4. So it's CnH2n, and I also have an oxygen, plus 2 and an oxygen, right? You'll see that number 6 also has an OH bonded to the second carbon there. So A, since I am given the condensed structural formula, I can start out first by writing out. So I always say it's good to write what you see. So it helps to first do the structure and then be able to figure out what is happening. So this is also an alcohol. Now the question would be, which one between number 5 and number 6 is a primary alcohol and which one is a secondary alcohol? So you can see that number 6, let's start with number 5. The carbon that is bonded to the OH is bonded to one other carbon atom, right? That would make 5 to be a primary alcohol. While for number 6, the carbon that is bonded to the OH is bonded to 2 other carbon atoms. So that would make number 6 a secondary alcohol. But if the carbon that is bonded to the OH was bonded to 3 other carbon atoms, then that would be a tertiary alcohol, right? Okay, let's move on. Let's look at number 7. Number 7, you were given the condensed So again, I'm going to start at the end. I'm going to start with the structural formula. 1, 2, 3, 4. So you've got 4 carbons, 3 hydrogens on this one, 2 on this one, and a double bond O, and a 3 hydrogens here. So remember, oxygen needs to have 2 bonds around it. So if you have a C bonded to an O, then it's going to be a double bond in this instance, right? And then it means there isn't any other hydrogen bonded to this carbon here. So if you look here, there's a C double bond O, and there's also carbon atoms bonded to this carbon that has the functional group. So this would be a ketone, right? The functional group is the carbon that has this double bond O must be bonded to 2 other carbon atoms, right? And the name of the functional group is a carbonyl. If you look at the general formula, that's going to be CN. How many do we have here? We have 1, 2, 3, and you would have, if these were hydrogens, 1, 2, 3, 4, 5, 6 hydrogens. So that's CN, H2N, and an oxygen, right? Now, if you were to name the ketone, if you look at this one that we have here, we don't have any substituents. We don't have any substituents. So the prefix, we'd have nothing. The parent is, we have 1, 2, 3, 4. So that's bute, right? But when we are naming the organic molecules that have the oxygen, then we use butane in our parent chain. So when we're doing the saturated and the unsaturated, then we use prop, bute, butane, butene. Now we use butane, right? Or propan or ethane. So we add an AN to our parent name, right? And then the double bond O is on the second carbon. Why? Because I've numbered from the right to give the lower position to the double bond O. Had I numbered from the left, it would be on position 3. So the IUPAC name would be butane 2O, right? That is number 7. If you look at number 7 and number 8, they are usually confused. Number 8 has a double bond O, but at the end of the carbon chain, or rather on the first carbon in the chain, right? So this one is not a ketone, it's an aldehyde. And the name of the functional group is a formyl, right? And you notice that the general formula, or rather, let's start, this is C, sorry about that. B is a formyl, is a double bond O and an H on the first carbon, right? And then if you look at the general formula, which is D, I was just super excited to go into the general formula. I don't know why. It's CnH2nO, right? And then the name, since the aldehyde is always on the first carbon, when you name it, you do not number the position of the functional group, right? So where the double bond O is in an aldehyde is always the first carbon. So when you name, this would be 1, 2, 3, 4. So that is butanal. That's the suffix for aldehydes, right? Let's move on to number 9. We are given a molecular formula here. It's C3H8, so you know what to do now by now. It's good for you to just know what you are given in a picture form, right? So I've got 3 carbons and 8 hydrogens. This is an alkane. There's single bonds only between adjacent carbon atoms, so that's an alkane, right? And then the functional group would be to just show that there's single bonds only between adjacent carbon atoms. And then the general formula is CnH2n. So you say I have 2 carbons. I'd have, these were hydrogens. There will be twice the number of hydrogens is 4. And then I have 2 more, so 2n plus 2, right? And then the IUPAC name is quite easy. My longest chain is 1, 2, 3. So, and the suffix is ane for alkanes. So that's propane for number 9, right? And then looking at the last one, you'll see that the functional group is the same as the one that we did in number 4. It's an alkene. So I'm just going to get straight into the naming because I've already done the functional groups and the general formula, right? So you have to prioritize the double bond, which means if I number from the left 1, 2, the double bond is in position 2. If I number from the right 1, 2, the double bond is still in position 2, right? So either or. But now, since whether I number from the left or right, it's still in the same position, I must also give the functional, not the functional group, rather the substituent, the lowest number possible. Because if I was to number from this side, then the functional group is in position 2, while the substituent would be in position 3. But if I number from this side, then the substituent is going to be in position 2, right? So I'm going to number from this side. Then my prefix, sorry about that, this would be my substituent. My prefix would be the methyl in position 2, and then there would be but, my longest chain. The double bond is in position 2, and it's an alkene, right? So that's 2 methyl but 2 ene. Right. I hope that was really helpful. I'll be posting more videos for exam prep. This is how you can help yourself to sort of put the knowledge together and actively remember the knowledge and link concepts, right? As I was saying, for the aldehyde, ketone, you can see that they both have the same general formula. For instance, you are linking knowledge there so that you can remember it more easily for your exam, right? Thank you for watching. Please like, subscribe, and share the video with other of your classmates or with your other classmates so that they can also be assisted. Thank you for watching, and there's more videos on organic compounds, so please have a look at those videos.